Use logarithmic differentiation to find g prime of x if g of x equals the square root of x minus 1 over x to the fourth plus 1. If we were to differentiate this explicitly, we would have to use the chain rule because we've got an expression inside the square root, and then we'd have to use the quotient rule on the expression inside, which is a lot. Let's see if we can avoid that much trouble by using logarithmic differentiation. I'm going to rewrite this as y equals the square root of x minus 1 over x to the fourth plus 1, just because it's easier notation to work with. And then let's take the natural log of both sides. That gives us ln of y equals ln of this whole square root. But remember that taking the square root of something is the same as raising it to the 1/2 power. So this is really just this fraction to the 1/2 power. And when we have the natural log of something to a power, we can pull that power out front. So we can actually rewrite the right-hand side as 1/2 times ln of x minus 1 over x to the fourth plus 1. We can even split this up even more because the logarithm of a quotient is equal to the difference of those logarithms. So we can rewrite the right-hand side as 1/2 of the whole thing, ln of x minus 1 minus ln of x to the fourth plus 1. Right, we've taken the logarithm of a quotient and written it as the difference of two logarithms. But that whole thing gets multiplied by 1/2, so we've got a 1/2 out front. And then we can actually distribute that 1/2 to each of those. ln of y equals 1/2 times ln of x minus 1 minus 1/2 ln of x to the fourth plus 1. Now, I've been writing out each one of these steps individually, but some of you might be really good at your laws of logarithms and your algebraic manipulations, and you might be able to get here from the very start, right? If we're taking the natural log of this square root, we know that the square root is the 1/2 power, so we pop out the 1/2 power, and we know that the log of a quotient is the difference of the logs, so you might be able to jump all the way from here directly down to the bottom where we've got the difference of these logs and each one is multiplied by 1/2. All right, everyone is different. Some students might be really comfortable with this because you are great with algebra and the laws of logarithms. Some students might not feel comfortable with that at all and want to write out each step one at a time. And either situation is okay, and anything in between. It's just we want to make sure that we understand why we're using the rules that we're using. Now, at this point, we can use implicit differentiation to take the derivative of both sides with respect to x. So I'm just going to write d over dx here just to say we're differentiating with respect to x. So the left-hand side, that's going to give us 1 over y times y prime. And then on the right-hand side, when we differentiate these, we're going to keep the 1/2s out front. So we've got 1/2 times. The derivative of ln of u is 1 over u. So this is going to be 1 over x minus 1 times the derivative of the inside. But the derivative of x minus 1 is just 1, so that's not bad. Minus 1/2 times, again, the derivative of ln of u is 1 over u. So this is going to be 1 over x to the fourth plus 1 times the derivative of the inside, which is 4x cubed. So now we can clean up the right-hand side a bit. This first one is just going to be 1 over 2 times x minus 1. And then we've got minus. If we look at the 2 and the 4 over there, we can reduce these by a factor of 2. So that's going to be 2 over 1. And then that's going to give us 2x cubed in the numerator. and x to the fourth plus 1 in the denominator. And then to get y prime alone, we need to multiply both sides by y. That's going to give us a factor of y on the right-hand side. But remember that y is equal to the square root of x minus 1 over x to the fourth plus 1. So that's going to be our y times what was already there, 1 over 2 times x minus 1 minus 2x cubed over x to the fourth plus 1. And that right there is our final answer for the derivative. We wrote out a lot of steps here, so it looks like a lot of work, but a lot of this was just laws of logarithms, and some of you might not need to write out all of those steps, as I mentioned earlier. So the actual work of taking derivatives ends up being a lot simpler. It's the last few steps, and I like this more than using the chain rule along with the power rule and the quotient rule. I think this is a little bit nicer in this situation. But you could go through and do it explicitly and see if you get the same answer, or at least an equivalent answer, and see if it takes more work or less work.